let's work a combination problem. Now, the trick with combination problems is to not panic. Just take a deep breath and work slowly. The first thing I always want you to do on a combination problem is find R equivalent. And I always want you to start by looking for series circuits because series are the easiest. And then you do the parallel. And you just quietly, calmly work your way until you have one equivalent resistance. The next thing you need to do is find the total current. Whoa, don't know what's wrong with my pen. I total. Okay, I'll just usually call that I. From there, you can find the current through each loop. You can find the voltage across each branch. Basically, you just have to work forwards and then backwards slowly and be careful. So let's try one. For the following circuit, find the equivalent resistance. Again, do not panic. See if you can see anything that's in series. Are these two in series? No, because there's something between them besides wire. These two are not in series because there's something between them besides wire. These are not in series. Okay, maybe nothing's in series. This is not in series with anything. Let's see, what about these two? You think those two are in series? Yeah, they are. So, first of all, let's label the resistors so we can do a numbering. Let's call this R1. Let's call this R2. This R3. This R4. And this R5. So R4 and R5 are in series because there's nothing between them except wire. So let's find R45. The equivalence of R45 is R4 plus R5. So it's 7 plus 7 or 14 ohms. Now I know you're not going to like this, but redraw it every time. There's R1, R3, R2, R2, R1, R3, and we have replaced R4 and R5, and wire is cheap and free, so go on and use it. Pen doesn't want to make a resistor here. R4 and R5. Now it's quite obvious that R4, 5 is in parallel with R3. So 1 over R3, 4, 5, you see my numbering, because it's going to combine 3, 4, and 5, is 1 over R3 plus 1 over R4, 5. Let's see what this is. So R3 is 7 ohms, so it's 1 over 7 plus 1 over 14. My least common denominator is 14, so let me do my 2 over 2 here. All right, so that becomes 14. So this is 2 plus 1 divided by 14, or 3 divided by 14. So R345 is equal to 14/3. Now, you can leave it like that, or you can get a decimal number. It doesn't matter. Let's go on and find it. It is 4.67. I know we've carried out a lot of stick figs here. All right, now we're going to replace. Here's R1. I don't know what's wrong with my pen. R1. This is R3, 4, 5, and this is R2. So, now when I get to this point, I just write R equivalent instead of 1, 2, 3, 4, 5. Is R1 plus R3, 4, 5 plus R2. Order doesn't matter. So this is 7 ohms plus 4.67 plus 1.5. And I add those up, and I get 13.1. I'm going to go and carry another decimal, 167. So let me rewrite this as 4.667. All right. So when I rewrite this, I get R equivalent right here is equal to 13.167 ohms. These ladders are scary looking. If necessary, just take a piece of paper and put it in front. Now I'm going to take a block and put it in front and show you what I mean. If I can find a block here. Just take a block and move it. All right. So that it's easier to see that those two 7 ohms are in series without looking at the rest of it. And then it'll be in parallel with that, and then the rest of it will be in series. So we have an equivalent resistance. Find the current in and the potential difference across a 1.5 ohm resistor. All right, to do these, you just kind of have to look. All right. The 1.5 ohm resistor is right here. All right, the first thing we need to do is find the total current. Now, it's pretty obvious, let me erase this, that, or it's not pretty obvious, that there's going to be a current coming out of the battery, I. And I see that the current is going to break off into 2 different branches here. But when it comes back, it's going to be at the same current I. So it turns out the battery current is the same, is going through the 1.5 ohm resistor. So we need to find the current coming out of the battery. So the voltage of the battery is I through the battery, R equivalent. So the current coming out is the voltage battery divided by R equivalent. So it is 12 volts divided by 13.167 ohms, or 0.911, let me erase that, 0.911 amps. So what's the voltage across this resistor? Well, the voltage across the 1.5 resistor is the current through the 1.5 resistor times the resistance of the 1.5 resistor. So the voltage is going to be the current, which is 0.911 amps, times the resistance of 1.5, or 1.367 volts. The trick for these problems, identify what you're looking for and avoid going off on really wild tangents. Work yourself all the way down till you can find the total current coming out, and then slowly work your way back.